be free riding off of Suhan's most recent North American trip. while he's over here. He told me he's been in the United States a total of, what, 60, 70 days this year?
This week is past 70, this year in the United States.
Yeah. So he almost, he lives here half a quarter of the year traveling. But as many of you know, Professor Chu was one of the theorists responsible for a lot of the early explosion of alternatives to EU in economics when the case was breaking down in the late 70s for us, and has produced more than one theoretical alternative. But also he's one of the theorists who, the handful of theorists who has become an active empirical researcher. And when I visited him about half a year ago and sat in with his research group, I heard a lot of talk about a lot of complex experiments involving a lot of tricky statistical issues and experimental issues, and it was all very interesting. So he's been doing a lot of stuff on, as the red says there, genes and genetic and behavioral stuff, and we'll get some of that today. And so thanks for coming and seeing us. It's good to see you again.
Thank you.
Suhan Chu.
This is anyway, my first job was at Arizona. I should put this. I should say, Vernon Smith gave me my first job at Arizona. At that point, I was purely an axiomatic choice theory kind of researcher. But through osmosis, I guess the value of experimental research, experimental laboratory-based test of theory, was certainly apparent to me. And so it's really great. I just came. I went from the Tucson meeting to George Mason, which is second stop for Vernon, of course. And then now we have Chapman, which is the rightful place. I'm going to make it, I'm going to crack a kind of a joke about Vernon, see whether you find it funny. Okay, but not at the moment, okay? So, as Nat mentioned, a lot of people are involved in doing some of this work, okay? I have a long-time vision theory co-author, Jacob Sergey, who has just moved to the University of North Carolina. We have, people in molecular genetics, people in imaging and experimental economics. So this is how we're going to organize. I'm trying to organize it this way. There's a chance that I may not get to talk about this last topic. Okay, hopefully we can talk about the three main topics. The first topic has to do with Keynes. Believe it or not, the second topic also has to do with Keynes, and so is the last topic, in particular this blurb here. So I will mention Keynes at least 3 times. The first insight of Keynes was in the abstract for my talk, and it actually led to 2 significant literature, one more significant than the other. One has to do with ambiguity, both aversion and affinity, and the second has to do with familiarity bias. And then there is a bit of a theory discussion of data, implications of data on various models of ambiguity too. The third sort of topic has to do with bringing biological or advances in biology can actually impact the development of behavior and thus experimental economics. And in particular, I want to share with you our finding linking gene, brain, and behavior in terms of something that has been suggested as underpinning the home market bias. So this is very, if it's not familiar, I'll familiarize you with it right now. This is from French and Porter's rather famous paper, 1991, on international home market bias. So you can see, pink is US stocks, green is Japanese stocks, and sort of grayish-blue is UK stocks. In each country, there is a superficially, visually disproportionate holding of domestic stocks. And this posed a superficial puzzle which has since led to dozens of, maybe hundreds of papers in finance, especially international finance, mostly about how to account for this using various consequence-based information, tax treatment, and so on. But there were subsequent follow-up studies. This is one such study by Huberman in Review of Financial Studies, and the idea is to control for the kind of transaction costs and information asymmetry associated with international finance markets. And in particular, these are the 7 baby bells. And turns out home market buyers, yeah. Well, all right. Anyway, somewhere along the line there should be a statement of home market buyers in the home. So this brings me to Keynes' insight in 1921. So Keynes has also written a textbook in probability theory, very much a research monograph of the time. And he wrote a very paradoxical sounding statement. If two probabilities are equal in degree, ought we, in choosing our course of action, to prefer that one which is based on the greater body of knowledge? I mean, this sounds like nonsense, you know? If the two things have the same probability, that's the end of the story. How can you prefer one that's based on the greater body of knowledge? After all, it's already been taken up, you know, in arriving at the probability. But this is Keynes, after all. So Keynes didn't stop at a statement. Keynes gave an example. And the example reappeared in a very famous paper. Oh, it's 1961, sorry, okay? Ellsberg's QJE paper. And by the way, I had the good fortune to meet Daniel Ellsberg in a conference in his honor in Vienna in 2010, and he acknowledged that he acknowledged Keynes' intellectual priority in his thesis, though he didn't cite it in the QJE paper. In the literature itself, people tend to call this the Ellsberg paradox. And so Keynes' view is that here is a 50-50 lottery, red and let's say red and blue. Okay, here is 100 red and 100, you don't know how many red and how many blue. While it is the case that we don't have frequentist probability, while the frequentist probability is not known here, from the decision-making point of view, these two events are valued equally. So the decision maker tend to associate betting on red from the unknown earn to be as valuable as betting on blue on the unknown earn. So from a strictly preference-based viewpoint, these two events are equally likely. And in 1921, there's only probability in town. So if the two events are complementary, equally likely, they have to be 50%. But Keynes is really making a statement about his own discomfort with probability theory. It's like, in both cases, he arrives at 50%, but this 50% is somehow a better 50% than this 50%. But they are both 50%. Okay? A very clever example, I think.
I actually like that 50% better.
Okay, why? Why do you like that? Why?
I think all you told me is that there's red and blue and there's 100 of them.
Right.
And that's it.
Yeah. So
and,
you like,
and I know you lie, so.
Oh, if I lie, no, let's say if I lie, but you get to choose the color. So which color do you prefer, red or black or blue?
Which color do I prefer?
You get to bet on the color.
I just know that you're playing with me. I just don't trust you at all.
Yeah, but at this point, hands off, there's an urn. There's an urn. Okay, you choose the color.
You know what Vernon would say?
Yeah, right.
He would say, what if I draw a green one?
Even though Vernon is not here to comment on a comment about him, I have a slide on him that's based on his paper in QJE 1969, which I'll see shortly. Okay.
But I understand you now.
Right. Okay. Thank you.
Okay.
So
Keynes also said that the probabilities should probably be divergent, like something like 0 divided by 0. It shouldn't even be a mathematical chance of that.
If that is in the book, I haven't come across it yet. But this one is very precise. Keynes' view is, how can two bets, I mean, he didn't quite say that, But same probabilities in his take, so I'm just adding to it. It's like two half-half gamble from one perspective are valued differently. That's puzzling. The more common Ellsbergian paradox is actually perhaps not as puzzling, because from the standard view, there's no known probability. So these two are different. If they're different, probably one is worth more. Which one? Well, this is worth more. But Keynes' view, it says that the two, in some sense, are the same. How can two things that are the same be valued different? Anyway, Vernon joined the fray in 1969, right? 8 years later. So Vernon actually proposed something very bold, in his time, in that time, okay? Why? Because he took Keynes' view. I think it was independent, because I don't recall Vernon citing Keynes either. But by that time, also paradox was known, and Vernon wrote a very short 4-page paper with very few equations. This is about it, okay? And then Vernon said, exactly what Keynes said, why are people talking about multiple, unknown probabilities? For all intent and purpose, many subjects or many people consider red and blue to be as good, in which case they are really saying they are half of them. Well, but we observe the two max to be different. That something must be different. What can it be? Well, in 1969 there was only expected utility in town. So if the two probabilities are the same, the utility better be different. So Vernon had this bold hypothesis. The same human being can have two different von Neumann-Morgenstern utility. A UK for known, UU for unknown. But his solution is a bit, it's something that we teach undergraduates now that you can't do this, right? This is like a cardinal, I would just call this a cardinal error. Because, this is utility function, known earn, utility function, unknown earn. So the decision maker may have two von Neumann-Morgenstern utility, but you don't want to have a conclusion based on the utility of 100 being greater than another utility of 100. What he might have done, had he, maybe he was very busy, he was like discovering, pioneering experimental economics, but had he had access to good RA support, someone might have read 1964, read 5 years before his paper. It has been shown, in econometrica, that two different decision makers, namely two different utility functions, can value the same risk differently. Not a mystery. Concavity does the job. So what does this suggest? Vernon actually originated the view that the risk attitude for the known earn is lower than for the unknown earn. You can also model it with more concave unknown utility than known utility. So this is a point of departure for us. So at any rate, so the one part of Keynes' insight led to this huge literature, right? So this is actually in a paper. Initially, I was going to present this paper, which is purely a behavioral study involving various shades of ambiguity. Then, as the days got closer, I thought maybe it's better to have somewhat of a more encompassing talk. Okay, so this paper I sent to Nat, and it's okay if you would like to look at it. Now, there's the two-color problem. There's also the three-color problem. In the two-color problem, you get to choose the color, the to earn from. In the three-color problem, actually, the color is chosen for you. How does it work? Because you have 90 balls, 30 red, blue and green adds to 60. So your bet is between red, which is 30, 1/3 chance, or let's say blue, which is 0 to 60. So potentially 0 chance to 2/3 chance. Which you prefer? Okay. So so at Root this year, the Die Hard Decision Theory Conference, this year it was held at Kellogg. People were lamenting in the room, how come we have only one data point? Actually, it's more like 2 data point, right? You know, 3 color or 2 urn. But in fact, we have more data points. Becker and Brownson in a JPE paper in '64, and then Curley and Yates was a OBH-DP paper in '85. They both studied variants of the the 2-color problem. In particular, I'm just discussing the Becker and Brownson. So besides unambiguous, fully ambiguous, he's also got this one. This one. Okay, let's just discuss it this way. So this is totally unambiguous. This is just a schematic which actually is used in experiments. Okay, so experiment, every bar is one possibility. So this one has only one possibility. It's 50 red, 50 black. Finish. It's a deck of 100 cards. This is the so-called fully ambiguous. So it's a deck of 100 cards in which every bar is possible. 0 red, 1 red, all the way to 100 red. And then of course correspondingly 100 black, all the way to 0 black. Becker and Brownson suggested this case, which is that there are 25 red and there are 25 black. But the number of red goes from 25 to 75, so does black, going from 25 to 75. Or you can just say both of them goes from 25 to 75. Okay. So arising from this design, it's actually very natural to think of a complementary design. So why don't, right, you have full ambiguity, this is partial ambiguity, we have another partial ambiguity, we just take the 2 n intervals. So 0 to 25 and 75 to 100. Here I want to share with you a quick observation that turns out to have significant implications on very sort of, let's say, rather important models in the literature. Notice that if you take the view, a view that was also advanced in Becker and Brownson, okay, in the paper, they already advocated the view. I'm looking for a conch block. It's here. In fact, I have extra. I sent it to me conch block. Anyway, so Becker and Brownson also thought that apart from the unknown number of unknown frequencies probability, perhaps some subjects are thinking the ambiguous urn is constructed in 2 stages. First, there's a stage of how many red, and then you put it together. So what is the number? What's then the question is, what's the distribution of the number of red? Well, a very convenient hypothesis is perhaps the number of red itself is uniformly distributed. So then the urn is just a 2-stage urn. First you draw a number 0 to 100, then you pick the number, and then the number of red is implemented into a deck. So if you take such a 2-stage view, you could then say ambiguity aversion is aversion to 2-stage rather than 1 stage. This is now a few papers in the literature doing that, but I will make a quick observation with you right now. So imagine this is uniform. If you take a 2-stage view, the number of red is uniformly distributed from 25 to 75. A 2-stage view would suggest that the number of red is uniformly distributed from 0 to 25, 75 to 100. If you take a mixture between these 2 lottery, half chance of this and half chance of this in the ex ante world of the 2-stage, what do you get? You actually get this, right? Half chance you get the interval, half chance you get the disjoint. Now, just recognizing that full ambiguity is a convex combination of interval and disjoint, that's one observation. Second observation is, what kind of preferences might the decision maker have in the first stage? Well, currently there are several papers adopting expected utility preference in the first stage. If you do that, what does that say about the valuation of a full ambiguity relative to interval and disjoint? Full ambiguity is a convex combination of interval and disjoint. So it cannot be the worst. It cannot be the best. It has to be intermediate between disjoint and interval. Without looking at data, I trust that you guys probably won't think that this is intermediate. If anything, this is likely to be the worst of the three. A disjoint, risk, ambiguity, and a disjoint ambiguity, and interval ambiguity. You take a mixture, you get full ambiguity. Is full ambiguity better than one of the two? I mean, okay. So this is so if this behavior is violated, namely, if this in fact is the worst of the three, then it immediately rules out a model in econometrica, Klimenov, Marinacci and Mukherjee, 2005, Seo, 2009, Bob Now in Management Science, 2006. All right. A third kind of partial ambiguity is to just take the end point of this. So you can also have an intuition right here. In a two-stage world, actually I want to just get a take from you guys. If you have this ambiguity compared with this, which do you prefer? An interval, all are possible, or just a two-end point of the interval? Which is better? What do you think subjects prefer? Interval. And I can guess your intuition, so let me guess, okay? You're thinking of some kind of mean preserving spread thing. So, you know, there are more things in between, right? So, who disagrees with Nat?
What subjects will like?
Yeah, whether they prefer the interval or the extreme. Just the two extreme points.
That's not fair because I think I ran this.
Okay, Nat, from what he said, you know that you're probably wrong, right?
Yeah, well, from what you said, right?
Okay, Nat is usually right, but not today. So this is the overall design for partial ambiguity. 50-50 interval all the way to full ambiguity. Full ambiguity taking out the middle all the way until 0 or 100. So it's not 50-50 now, it's either all red or no red. Okay? For 2 point, 50-50, and then you get the endpoint 40 red or 60 red, 30 or 70, 20 or 80, 10 or 90, and then no red or 100 red. So you can see these two are shared. These two are shared, and this one is shared with this one. There are a total of 15 lotteries, all reflecting different stages of ambiguity, except for this case with no ambiguity. The intuition for us were experimented. Sometimes we are surprised by our data, but in this case, the three authors were all thinking that this is less ambiguous than this because there's so many more possibilities. There are very few possibilities. Of course, there's also the intuition of mean preserving increase in some side in ambiguity. So it's a matter of which one turned out to be the case. Here's the data. The red is the interval ambiguity. It's 50 minus n, 50 plus n. So the bigger the n, the bigger the spread. So utility, this is the mean switching point in the Holt-Lowry priceless design. 5 is actually risk neutrality, and on average we don't get 5. So the highest value is 50-50 unambiguous, it's here. It progressively drops to around 2.6. And this is the red line. The blue line is consistently above red, the 2-point extreme, and with a curious sort of reversal upwards. And this is a bit puzzling. And then this is the same point, notice from the diagram. So from the full ambiguity, when we take out the middle, it increases in value until 0 or 100. So by the intuition of mean preserving increase, full ambiguity should be better than 0 or 100, because full ambiguity has everything inside. But in fact, full ambiguity is the worst. Okay?
So what do you mean by the Holt-Lowry here? Is it a price list?
Oh,
is it certain outcomes?
The tasks are like this. Yeah, here's the task.
Okay.
You bet. Here's a bet. Here's the money. So.
Okay. Yeah. Sure thing.
Yes.
Okay.
Yeah, it's a sure thing. We have a second design. That looks like this. Yeah. So these are all skewed. So for this design, subjects are required to bet on red. And I think Dave just now was mentioning the so-called suspicion hypothesis, which we cannot ignore. So if you, especially when subjects cannot choose number, we can maybe stack the cards with no red, and then it will surely lose, right? So if anything, the suspicion hypothesis ought to enhance the appeal of unambiguous. I mean, because you can't choose color. Yeah. Anyway, here's the data. So for 50-50, people are ambiguity averse. Only 10% choose ambiguous lottery. For 40 versus 60, so 50 versus 100, 40 versus 80, so 0 to 80 red cards, and then 30 versus 0 to 60 red cards, all the way to the skewest case, most skewed case, 5 versus 0 to 10 red cards. Notice that there's a switch around 0.5. You see? I just want to emphasize 1/3. If you imagine there's a 1/3 and you go up there, I think you get 0.5 to maybe 3 decimal places. Anyway, so if you recall what we just said just now, the standard alphabet paradox comes in two varieties, the 2N and the 3-color. For the 3-color, it's almost textbook, and I'm also guilty of the same sort of crime. We just tell students, oh, people routinely prefer the 30 red to betting on blue from 0 to 60, with the exception of Dave. Okay, but now, according to this data, people are probably ambiguity neutral at 1/3, and I want to then mention, as it turns out, here, there are 3 papers. This is published in Journal of Risk and Uncertainty this year. Binmore, Stewart, and Chalmers, Carney, and Levine is still kicking around as a working paper. And McKenna et al. Is not something that you would ordinarily read, neither would I. It's in the Journal of Sleep Research. But it's actually the first published paper that I'm aware of that demonstrated that for the classical 3-color paradox, they found ambiguity neutrality. Not only did they find ambiguity neutrality before sleep deprivation, because this is a sleep deprivation study. Subjects are deprived of 23 straight hours of sleep before they get retested. They remain ambiguity neutral. So that's 07. So in some sense, this result was replicated by Binmore et al. And Chalmers et al. Neither of them are aware of this paper because we don't read sleep research. Anyway, but I just met him at the Tucson conference. One of the authors is David Dickinson. And it was really fortunate, I think I missed my flight or something like that. I ran him the airport. And then we discussed it, and then I learned about this paper. So we have at least 3 papers, 3 published papers in various stages of publication, including one that studies the robustness of ambiguity neutrality, and look at what we have done, right? We found the reason for that. Because people, perhaps, on average, are both ambiguity averse when ambiguity is somewhat not too skewed, somewhat symmetric, and tend to be ambiguity seeking when ambiguity is, let's say, highly skewed. For our subject, magically, at 1/3, people are ambiguity neutral. So, it would be I think it's a misconclusion in Binmore's paper, because I met one of the co-authors actually at LSD last year when he was saying, something, we found ambiguity neutrality. Well, sure, you found the intersection, the switchover point. All right. So this is a summary of the empirical data on the partial ambiguity, right? People have increasing aversion to the size of ambiguity. Interval and disjoint, they are also averse to spread. But except at the end there's a reversal. Interestingly, point is preferred to interval, and interval is preferred to disjoint. I guess that is reasonable. Interval preferred to disjoint is reasonable. But point preferred to interval is counterintuitive if you take the two-stage view. And also the concurrence of affinity when ambiguity is not very skewed, and affinity when ambiguity is skewed.
Are there evolutionary reasons why this might be so?
Wow, great that you asked the question of evolution. In my concluding slide, I will actually have a statement talking about positive selection of a SNP, which is implicated in this kind of work. So it's not just evolutionary.
You need to tell this audience what you mean by
SNPs.
There's a couple of people in here who know what you want.
Okay, the human genome, whatever that means, right, consists of 3 billion genetic variants. This kind of variants are called SNPs, so it's single nucleotide polymorphism. Right? So it's short form of SNP, and then it's pronounced as SNP. Okay, so 1 out of 3 billion is the conclusion of the third part of the paper. 1 out of 3 billion. Okay, there's no kidding here. All right.
That sounds suspect.
Was it?
That sounds very suspect. Found the 1 in 3 billion.
No.
They've got good statisticians in there.
Yeah.
They're correcting for the multiple.
Oh, I was thinking
the
it was
massive
Chu
multiple
found this.
comparison. Oh, okay.
I'm also suspicious, so we should be jointly suspicious. Right. Now, I want to tell you the second strand. The second strand of the literature is the work of Fox and Tversky in 1995 in QJE as well on familiarity bias. So they studied the valuation of 4 different lotteries using 60 degrees Fahrenheit. These are UC Berkeley undergraduate subjects. The task was hypothetical, but the payoff is $100. So if tomorrow's San Francisco temperature is to be above 60 degrees Fahrenheit, and you receive $100, how much is this bet worth to you? So on average, they evaluate at $22, $23. Below is valued about $18. So this suggests that UC Berkeley undergraduate that day thought that above is more likely than below. And similarly, Istanbul, which has the same latitude, above is valued more than below. Does this picture raise some bells? Right? Is there something wrong with this picture? I mean, these are the data.
Were any of the people in San Francisco
The same
from
people.
Istanbul?
Was it? No, all of them are.
You could have found one.
Of course, yeah. So these are all UC, but I think they make sure that they are not immigrants from Turkey.
Okay, there you go.
Okay, so is there something wrong with the data?
They don't add up to the same value.
They really don't add up in a very serious way, right? You see, this is less than half chance by their revealed behavior. This is more than half chance by their revealed behavior. More than half chance of receiving $100 worth less than half chance of receiving $100. This is almost illustrating Keynes' point, except that the probabilities are not equal, and then subsequently people talk about ambiguity and so on. We're going to put all those things to rest with another study. In this study. But let me just mention an insight of Tversky. So in 3 or 4 papers in the 90s, Tversky and Fox, Tversky and Heath, even the Tversky and Kahneman paper in 1992 also mentioned the idea of familiarity bias, and they suggested a link with the international home market bias phenomenon, which in the 90s remained a subject of contention. However, Tversky did pass away before the publication of Koval and Moskowitz and Huberman. Nevertheless, in a sense, he and his co-authors anticipated a stronger link between familiarity bias and the market phenomenon called, let's say, home market bias in the context of domestic home market bias. So it's a bit stronger. So we're going to make it even stronger, hopefully. So our follow-up take on familiarity bias, which is part of the report, the paper or the study and the report overall, is like this. So these are, of course, anticipating Dave's question again. They're all in Beijing. Okay. So 325 subjects recruited in the Beijing area. They are basically college students. They have to bet on either the temperature of Beijing being an odd number or even number versus Tokyo. They get to pick the odd or even. The temperature is published on Yahoo, and when we begin the experiment, we actually sort of come up with some mechanism to just draw a date in history, like so many years later, what day, what month. And then you guys indicate your bet, and then of course we can all check whether you have won or lost. So tell me, what do you think subjects do? Do they pick Beijing or Tokyo? What kind of proportion? 100% Tokyo? 50%? What is your sense?
100% Beijing, right? They're Beijing students.
Pay 11,
7.5.
13,
60,
60% pick what?
60% Beijing.
Interesting.
That's rule number 1.
What?
So this is, let me just
Right.
ask you about this. So this is the thermometer gamble kind of thing where, right?
Yeah.
This is like a machinist thing where you take
Yeah.
subjective
Yeah.
ambiguity and turn it into objective
Well,
probability, right?
yeah.
So Martin says that
Mhm.
that's a problem for those first stage EU type models, right? Isn't that what his argument is? So that maybe this thing breaks down for this example and you have people choose.
Net is on the Formula 500 circuit. It's a bit fast. Okay. Okay, but Mark Machina did write a very extended paper. It's basically a monograph in ET. Like I think it's a 98-page paper in ET, talking about almost subjective probability. Almost objective subjective probability, or subjective objective probability. Anyway, but I think when we studied pi, I remember even as a high school student, the instructor would say something like, you know, the 59,000 digit of pi is a random number. I think we'll grant that, right? Okay, what is the 25th digit of pi? Is it odd or even number? So, in a sense, there's always this intuition that the trailing digit of something that is sort of, you know, some kind of fraction that we cannot predict itself is unpredictable. To the extent that we will be indifferent between betting on the 29th digit of pi, is it 0, 1, 2, or even less than 5, more than 6, whatever. Okay? So on that principle, I would say subjects are like what Keynes suggests. Odd or even, who cares? But they care between Tokyo and Beijing. If I give them the same amount, exactly, the intuition is they will all pick Beijing. So you've got to actually get them to pick Tokyo. And for us, we must get them to pick Tokyo for the very good reason that we're doing genetics. If everybody picks Beijing, we'll have no finding. So we actually did pretest before we do the real thing. So in pretest, 11 and 13 delivers almost a balanced thing. For the real thing, the answer is 40.4% pick Beijing. So 59.6 pick Tokyo.
So it would depend also on the price, right?
Of course,
I mean,
of course.
If you
Yeah.
give it to 12, you get more Beijing,
right.
you know. So it's just like,
Yeah.
how much do you pay for that bias?
No, the optimal thing we want is 50-50.
Yeah.
We got reasonably
Just
close.
good, yeah.
All right. Now, when I was doing this with my co-author in Berkeley, I think one summer several years ago, a very respected finance colleague who was then chair, his name is Jonathan Burke, he just cracked up laughing. Oh, you guys, you're using student subjects and you pay Mickey Mouse money. Who gives a shit? You know? So never mind. We're very constructive researchers, you know, want to be engaged by finance professors, right? So as I say, and Jacob Sergey is actually a finance person. So he's asking, what kind of subjects? He said, go look for traders. Go to the stock exchange. Fine. All right. So we designed this experiment with him. All right. My RA, actually my graduate student, happened to be visiting home, so she got herself a free ticket. You know, because I just say, you run this experiment for me, I'll pay your round trip home, and she's already back. You know, so it's a freebie for her. Anyway, so she went to the Shanghai Stock Exchange. As it turned out, she's very enterprising. She just sneaked in. She did 25 subjects before being chased out.
I love it. No IFREE in that thing.
Yeah, anyway. But
Did you pass the human subjects review board?
oh, no, we have IRB approval to do behavioral studies. And I didn't know that she was committing a crime. Anyway,
Wonderful.
so when we did this study, this is pre-approved by Jonathan Burke. He said that for this study, every one of the trader will pick 280. It's Dow Jones. I mean, this is the mother of all exchanges, right? And plus it pays more. And it's trailing digit, odd and even. So I said, so let's have a bet. What's the criteria? He said, the criteria is 100%. I mean, you know, Vernon will not forgive me if I accept a bet based on 100%, right?
Yeah. What precisely was the bet? So this
Oh.
was, what was the authority on exactly
No.
what the price was?
No, Jonathan said if one person
This
picks
is Jonathan
Shanghai,
Burke?
Jonathan Burke, yeah,
Burke,
his name,
the Burke name?
B-E-R-K, right? His name.
No,
No,
that's
no.
a different.
Different Burke, okay.
Okay. Anyway, he said that if one person picks
No problem.
Shanghai, I win the bet.
Uh-huh.
But I think that's not fair, right?
No.
Because he doesn't know experimenting.
Okay, yeah, but this is, how many,
25. It turns out we had 25 subjects. So
yeah, no, but the payment.
payments, well,
Yeah, but
That's
this is like 30,
That's
$35.
what are they
But
being
that's
asked to wage?
peanuts for a
Oh,
trader. That's like
it-
a,
I
less than
agree.
$1 for you.
No, but what
Yeah.
is the authority on actually what the price is? Where do you look to make that authoritative decision?
Well, actually,
So, I mean, what familiarity may be the ability to manipulate whatever it is that convey prices. It's
Yeah.
true that Dow Jones you can see anywhere, but also you can,
odd and
you know,
even.
maybe your local newspaper's on the take and they
Yeah,
don't mind.
no, it's tomorrow. Tomorrow's market closing, we bet now.
Yeah.
And the Dow Jones is published
Where do
globally.
you get the quote for the?
Oh no, the quote is on the net.
I know it's on the net, but
No,
it's
it
in
doesn't-
different places on the net.
No,
but there's
excuse
only
me.
one
I said, no.
closing.
When it comes to Dow Jones, I don't think you will get two different trading digits.
The question is whether it
Well,
can be manipulated in
but-
some outlet, yeah.
No.
But seriously, okay, it's published tomorrow.
It's published, but I could put it, in my newspaper, it could be a digit off. No one would give a shit.
It's not a newspaper, right? We can go to the Dow Jones
Okay, is
website.
that what you did? That's the question.
Well, the thing is,
That's a cost.
no, excuse
That's
me.
a cost, that's a transaction
No,
cost.
the subject themselves can check whether they want money, and then we better pay if they
Yeah,
want.
yes, and then they can argue with you over the dollar.
Well, if they did argue, we'll have to deal with it, right? You know, as
Yeah,
it
but
turns
that's
out.
cost.
Yeah.
See, the familiarity here might be involved with the transactions cost.
By the way, I think that
Prices.
I don't think the cost is different for Shanghai. You can also argue whether it's an odd or even number tomorrow.
Yes, but there
Yeah.
might be more people looking at the Shanghai exchange in China and they'll
Okay.
look at you and say, look, this guy's a crook. He told me the Shanghai exchange
Okay.
was really this.
Let me just posit the possibility that this could be the case.
Yeah.
But nevertheless, my respected finance colleague wanted to bet on 0% betting, picking Shanghai. But I remember Vernon's lesson, you know, you got to do things more honestly. So we agreed on 10%. So if 3 or more people pick Shanghai, I win. And I really won. By how much?
12%.
12% or 12 people? 18 people pick Shanghai. Quite surprising, huh? Yeah.
So wait,
So that was closer to my 60%.
Yeah, actually. Now, then we also want to test whether they might actually know something. They think they know something, like the odd and even business. Well, indeed, I think if you ask them whether the market will go up or down tomorrow, presumably Shanghai trader, whether they actually know, may have more confidence about Shanghai up and down than Dow Jones up and down. 3 more people pick Shanghai. And this is not super significant, it's 0.07, so we're not talking about doubling the sample. I'm prepared to bet with you guys that when we double, it will be less than 0.05. Okay.
Was that the same sample?
Same sample, yeah. I just asked them, one question is odd even, another question is up or down.
So those aren't different.
Yeah. What is up different?
Those
They're
two-
not different.
They're
Oh,
18
no,
and 20.
Typically not different.
This is odd and even, right? 18.7, and then 3 more switch to Shanghai when it's odd.
That's
up
not
and-
significant.
0.07. Okay, net. Money, dinner. $10.
I don't, that's too small a sample.
No, well, okay, it's possible the net is correct because my RA says it's 0.07. Between my RA and net, I have a lot more respect for net. But still, I'm willing to bet $10. Okay, then we have an experiment, home market bias in the lab. Here's the experiment. We constructed 7 stocks, but they are all based on the trading digit of the closing price of the respective stocks in the German stock exchange. Notice that all
I
of
think just one thing. So when you won the bet, did he say anything like, you know,
They're just stupid in Shanghai?
Oh, come to think of it.
He must have said
No,
something, right?
no, he's sort of, I think he was a bit speechless. It's like, I mean, it's not like he said, you're right. He didn't say that.
Okay.
but he didn't quite have, I mean, he actually doesn't have alternative to account for this. He's like, okay. So now, this is something I haven't shown him. Now, we have 3 of the stocks. These stocks pay either R times, 2.5 or 2.7 or 0. Subjects can either put money. You see, subjects are given 10,000 points, which are equivalent to 10 euros. They can have all cash or put up to, or invest in up to 3 stocks in whatever proportion, and indicate whether they bet odd or even in each case. So look at, there are 3 of them at 2.7 return, you see. Federal, IDG, and Homac. 4 of them at 2.5 return. Volkswagen, Lufthansa, Puma, Wacker. So what is your prediction on the subject behavior?
Where are they from?
These are German students. Oh, so this is done in Max Planck. And yeah, these are all stocks in the German stock exchange.
Okay.
Yeah. Finance theory has a very crisp prediction. You should hold, if you hold any stocks, they should be 7.
Right.
And if you believe in risk aversion and portfolio allocation, you should diversify equally among the 3, 2.7. Do you think this holds out? Of course not, otherwise I won't be talking, right? But this is the result. People who only hold, finance theory explains 37% of subject behavior. So 0 means they don't have any 2.7. But the second group is almost as prominent. It's all 31% holds only 2.5. Right? And then 2, 2.5, 1, 2.5. This is all 2.7. This is the overall holding. You can see Volkswagen got the most investment. Okay, it's got 2.5. Second is also familiar. See, Lufthansa and Puma. You see, of course these 2 are very close now. Like Homac. So the behavioral regularity, I think we're just really saying something that Keynes said in 1921, right? Risk attitude is not independent of the source of uncertainty, and it could be in particular linked to the familiarity. So what's the lesson? The lesson is, do not be fooled by equal likelihood in the usual sense. 50-50, another 50-50 doesn't make them the same. When are they the same? Wow, why don't we have a stronger definition of equally likely? 2 events are equally likely when you treat them the same. Rather than, if they're the same, if they're the same probability, they should be treated the same. Well, 1921, Keynes already cast doubt on that. Now I think we have a bunch of behavioral evidence. So we have a very fine, a very precise definition. This is what I did with Jacob Segate. 2 events are really equally likely, or we call it exchangeable, if you don't care how you assign outcomes to the 2 events. See, X associated with E, X prime to E prime, or X prime to E, X to E prime, F is whatever else summarized. If it's not E or E prime, then it's according to F. If for every F, for every X and X prime, these 2 are indifferent, then this axiom just is recognizing behavior, right? If a subject behaves this way, the subject is telling you, I see no difference between E and E prime, then it's equally likely. So with such a definition, we can then immediately define more likely. More likely simply means an event containing something which is equally likely. So, some event exchangeable. So with such a definition, we're at a crossroad. If your end point is to have a nice, pristine Savasian world of a single probability measure that is always consistent, all the small gamblers are all conditionalized and Bayesian updated, then you should have a complete likelihood relation. Okay, that's one branch of the crossroad. But if you don't want to, if you want to account for Keynesian intuition as manifested in Ellsberg and Fox-Tversky, then you don't want to complete it, right? Don't want to complete. So to complete, if you want to complete, first of all, we are in the classical domain of complete and transitivity of the preference relation. and completeness of the preference of the likelihood relation is a different completeness. There's all events are comparable. Then we just need 2 more axioms on likelihood. I won't spend time on it. It's in the paper. So we published, my co-author and I published a paper in Econometrica in 06, in which we only assume these 2 more axioms, no continuity and no monotonicity, and we actually deliver having probabilistic behavior globally. So this is a super friendly model. You can match it to any non-expected utility. But of course, this is not our end point. We're more interested in not complete. So not to complete, we kept, so we drop one axiom, no more completeness of the preference, of the likelihood relation. We strengthen the non-CACH. We strengthen one of the axioms, okay? No time for that. And then we published a paper, this is the lead article in JET 08, called Small Worlds, Modeling Attitude Towards Sources of Uncertainty. An immediate payoff is Vernon-Smith's approach is okay, right? Because
I could have told you that.
that's intuition.
It's a lot of work, you know.
This is an axiomatization of Vernon-Smith's intuition. But sure. So in particular, different. In other words, the paper. Of course, you can also ask Dave, okay? But the paper or Dave will tell you from now on you can use different von Neumann-Morgenstern utility in the same decision maker to do your applied, micro or macro modeling.
Does that allow comparability between 2 different small worlds?
That's the whole point. If it's comparable, then the 2 utility functions will become ordinarily equivalent. Think of the Smith's paper 69. He's got 2 utility functions, and then the 2 rate on known earn, rate on unknown earn are not indifferent. But if the 2 utility functions are ordinary equivalent, like affine transmission, then the 2 will become equivalent because the certain equivalent will be the same. To be non-equivalent, the curvature must be more concave in one than the other, and that makes.
I understand that. This allows you to have people placing bets in both small worlds. It's not something that keeps you within one small world.
Oh, it doesn't. It's just that, if you want me to bet on Tokyo, you're going to pay me more. The same person.
Okay.
So I will be showing you how to apply source-dependent SEU to do 2 experimental studies. But first we'll start discuss some theoretical implications of all this data.
May I ask a clarifying question?
Yeah,
So
go ahead.
you're using the source dependence language, and I know that some of the people who push the notion of source dependence are trying to locate this in the probability weights rather than in
No, it doesn't
utility
matter.
functions, and
No,
so you're.
it doesn't matter.
Oh, so you.
It
But,
doesn't.
but you were telling us Vernon's approach is okay.
Vernon's approach is the easiest approach.
Is the
It's
easiest.
expected utility. But you can also have rank dependent, and you can have source dependent in the probability function.
And so it doesn't matter.
It doesn't matter. I mean,
Under the axioms, is it even identifiable?
No.
Are
No,
there,
no.
can the theory say, what, whether I should? Are these sort of minimal axioms for allowing it for there to be any kind of source dependent in either one of the functions, or does it doesn't rule one out?
You see, notice that in the paper, the small worlds paper, we also don't have continuity. We also don't have monotonicity. Therefore, we are silent on the specific preference specification. You can match our approach to rank dependent, to expected utility, to weighted utility, to prospect theory, whatever. It's cool. Yeah, it's very, very flexible. I'll show you how it can be used in the context of the Smithian approach.
So are the axioms things that can be tested? I mean, because sometimes the technical axioms like Archimedean axioms are things you can deal with, right?
Okay, I'm going to describe Archimedean in less than 39 seconds.
Okay.
And it will be very shocking because this is one Archimedean axiom that can be understood by a high school student even in the Orange County school system. Okay?
I'm not asking whether we can understand it. I'm asking whether we can test it.
I think you have to judge whether it can be tested, but I'll state the axiom, okay? Every sequence of events that are non-null, that means no positive probability, pairwise exchangeable, that means equally likely, and pairwise disjoint must be finite. So here's a high school student from at Orange County. He has just learned that 100% is the most probability you can have. So I just tell him, every little thing has some probability, and then there are a whole bunch of them. They are all equal, and they don't intersect. That means, how many can that be? Well, 1 over p maximum, right? So it's the kind of discussion. Anyway, that's the axiom. Whether it can be tested, okay, I don't have an immediate answer, but my gut feeling is testable. Okay, so
I gotta bring in a high school student here. I think
This is what a high school student would say. What does it mean that they don't intersect?
I think there's a way to say it. I think you need Shakespeare.
What I'm wondering is whether the general notion, that level of generality, is the notion of source dependence empirically empty. Okay, because you're saying that, well, all I have to do is add to transitivity and completeness this extra axiom, which doesn't sound like it's even testable. And I can have weighting functions vary across sources. I can have utility functions vary across sources. So is the general...
Okay, during lunch, Nat has emphasized that he's not a patient man. I think we're noticing that aspect of Nat right now. So I just ask you for about 15 minutes more patience.
Okay.
Things will emerge.
Okay.
All right, so quickly, so to do some theory, we need to make some assumption like people really are different between red and black in my partial ambiguity design, and also for the conditional symmetry, right? If they're in the 0-10 region, they're indifferent between black and red, except that I cannot let them pick black because there are a lot of blacks here. Okay, so with that in mind, I'm going to fast forward a little bit. So Showcase expected utility replaces probability in an expected utility function with a capacity that is not constrained to add up to 1. So you can have capacity of red equal capacity of black, but the two add together can be less than 1, can be greater than 1. So because of that flexibility, in fact, Showcase expected utility can explain all the data trivially. So we shall not spend more time because Nat will not be very happy with this model, also neither am I. Okay, the next one is the famous maximum expected utility of Gilbert-Schmeidler. Now, I have had this discussion with David Schmeidler last October in actually Tel Aviv. He also acknowledged the following. Somehow, the convex set of priors in the maximum model ought to be related to the convexification of the actual priors. So you notice in this data, interval and 2 point have the same convex set of prior. And therefore, and also disjoint has constant convex set of prior. It's always 0 to 100, Either full ambiguity, take out a middle, and then all the way until 0 to 100. So maximum will predict that all of these lotteries will be indifferent. Of course, it doesn't bear out in terms of implication. Moreover, for part 2, it simply cannot account for any ambiguity affinity. So David Schmeidler is cool of this. Although other adherents of the maximum model sometimes tells me, no, the interval just keeps moving up and down depending on the lottery. So this is in the realm of I think a beauty contest. I don't want to spend too much time on it. Now the alpha maximum also led to a jet in an econometrical paper, in which you take the kind of an alpha combination of the min and the max. But the alpha itself can actually depend on the lottery, so this is pretty flexible. In principle, it can explain a lot of things. But it probably cannot explain this part if you apply the notion that the set of convex set of prior, pi I, is related to the underlying convexification of the actual priors. If you apply that criteria, of course, this will imply all kinds of indifference as long as the endpoints are the same. There's variational preference of Macaroni, Nachi, and Rosacchini, also econometrica. So there are some fine points here, but I just want to make mention now that in this model, ambiguity aversion is an axiom. Therefore, it can also not apply to part 2. Another econometric paper, Siniscalchi, vector expected utility. Here there is an ambiguity. Here's like there's expected utility and an ambiguity term. The ambiguity term is rather flexible. Is vector dimension. It has potentially infinite number of potential ambiguity factors. So in every case, the model can exhibit both either ambiguity aversion or ambiguity seeking, depending on whether this A function is concave ambiguity aversion or convex ambiguity seeking. And because it's got so many dimensions, it can have a lot of Saddle properties, so it can actually do both. So we make a theoretical observation that for skewed ambiguity, the comparison is actually for every p between 0 and half, we're comparing with ambiguity from 0 to 2p. So the possible comparison in theory, not data, because we have finite number of data, the number of comparison is actually a continuum, all the way from 0 to half. So the data is suggesting that human attitude towards skewed ambiguity can vary continually, okay, or along the continuum. Therefore, it goes beyond the countable number of adjustment factor. So in that sense, we also take the view that vector expected utility fails in that one case. So this is vector expected utility. This is all these others. So and then Shokei is sort of trivially successful. And now I want to make some comments on the two-stage, but we actually have already made one comment, namely the betweenness comment. So because full ambiguity is a convex combination of disjoint and interval, therefore, not only can you not use expected utility for the first stage, as illustrated in the data, because interval is the worst loss rate of all of them. Okay, so the more calibrated property is actually betweenness, because betweenness literally says that the value, the utility, or the certain equivalent of any mixture cannot be better than the better or worse than the worst. Okay, so all betweenness models cannot be used for the first stage. That includes my model and Gould's model. In the two-stage world, there are two other approaches. You can use non-betweenness. In fact, Uzi Siegel published an AR paper using rank-dependent utility twice, the same model, and on the Becker-Brownson intuition of two stages. And that model actually can account for almost all the data except for a cross-group comparison. That point being better than interval, interval better than disjoint. It can also account for concurrence of affinity for ambiguity and aversion for ambiguity when n is moderate. So this is a lot of algebra, but this algebra tells you that another approach is simply use two different rank dependent, one for stage 1, one for stage 2. This can be encompassed in the work of Ergin and Gould in 2009 published in JETS, in which they do not insist on expected utility for both stages. So if you apply rank dependent for both stages, it is possible to account for all of them. So this brings us to the source preference approach, and that has raised some questions, and the questions can be addressed. Okay. Oh, we have already discussed, right? So I'll just show you how source preference works in conjunction with the interval ambiguity. Notice, here you have n to 1 minus n. This is altogether 1 minus 2. In terms of objective probability, what's the chance of being in the ambiguous world? It's 1 minus 2n. You have 2n chance of being in the known world, see? N red and n black. So the way you look at it is, you have 2n chance of receiving, delta is the notation for receiving something. Receiving what? Receiving C. C being the certainty equivalent of a half-half loss rate from a known Earth or known deck. So this is known, right? N red, N black. So you have 2n chance of landing here. How valuable is landing there? Well, it's as valuable as C. But you have 1 minus 2n chance of landing here. How valuable? Well, it's as valuable as D. D is a certain equivalent of the unknown deck. Half chance of W, half chance of 0, but you don't know how many within this world. So also on balance, you can already see, from the source perspective, the utility of this guy will increase as distinct strings because C is greater than D. C is the unambiguous certain equivalent. This is ambiguous equivalent. So as a result of spread, the more ambiguous, the lower, the closer to D. The less ambiguous, the closer to C. So this is one application. Disjoint is sort of similar. So I don't want to take time from this because I show you some action. But this is kind of idea and it's in the paper. And then 2 point, you can see. Well, skill also is no big deal. So all we are comparing is n chance, this is precise, right? N chance of getting W dollars or 0. Here is 2n chance of getting what? Getting D. This is an ambiguous lottery. And 1 minus 2n chance of getting 0. So you can see when you compare this kind of objects, you need non-expected utility. Expected utility would not help you. Okay. A cross-group comparison is really straightforward for the source preference approach. Let's compare interval and 2 point. See, interval and 2 point, they both have 1 minus 2n chance of getting the known lottery, or the certain equivalent for the known lottery, but 2n chance of, in the case of interval, is totally unknown, but in the case of 2 point, it's actually all or nothing. I didn't define for you. So C prime is the utility, is a certain equivalent of a all red or no red lottery. So that lottery is better than D, but lower than C. So from this expression, you can already see 2 point will be better than interval. And then you look at disjoint and interval, you can also make a comparison. This is 2n chance of D. Okay, so for interval, 50 plus or minus n. So 2n ambiguous, 1 minus 2n C. Okay. Now, if it's disjoint, then it's the opposite. 2n chance of D, 1 minus 2n C prime, and C prime is worse than C. So interval is better than disjoint. Okay. Okay. Anyway, so this is a whole table of about 10 models. Yeah, actually there are 10 models. Source and two-stage NEU both perform pretty well, except the source cannot account for the last reversal. Not in our current analysis. I'm still thinking whether we can, but I think we cannot. Okay, at this point cannot. So it's as if my subjects, some of my subjects are looking at 2 points increasingly worse, but 50% more than those subjects actually are decreasing all the way, like 2 point, right? 50, 50, 20, 40, 60, all the way to 10, 90. But when it goes to 0, 100, more subjects actually flip. And that value is statistically insignificantly different from 50, 50. So I can't say any more than maybe subjects are sometimes looking at it as a 50, 50 lottery. And that's life. Okay? Right. This is the conclusion for the behavioral part. You can see, it's useful as well. So I will take the last one. Have I exceeded my time?
No, you got 20 minutes, but
wow.
I need a drink real quick. Either that or a nap. One of the two.
It's amazing, I didn't expect that I could have 20 minutes at this point. Okay, so far. Okay, so now we can link decision theory with some biology plus a discussion of conscious and unconscious. And there's another quote from Keynes. So this is a very famous quote, it's often appeared in his 36 general theory, when he was actually comparing British investors and investors across the ocean in New York, how they sometimes engage in like high frequency trading. For Keynes was more than 1 trade a week. Anyway, so he was thinking enterprise, entrepreneurs, they actually need to take decisions often as a result of animal spirits. Otherwise, if they keep calculating, maybe they won't do a startup. Okay. So this is Keynes' explicit suggestion as early as 1936 that beyond psychology, there is biology. Okay. Now, Keynes' view, I think, has been joined by the work of Antonio Damasio, who himself, I think, followed the work of William James. So a long time ago, in psychology, people have already think that sometimes you need to feel something. Like Fear. Fear is something you cannot intellectualize. You need to feel fear. Or heartthrob. You need to, if you have a heartthrob, you know it. But it's like, you know, like you cannot have a heartthrob, right? Anyway, so in fact, the Damasio suggests that it maybe biologically somatic markers help direct our attention towards advantageous options. Otherwise, many things are happening. You know, like fire. See, your somatic marker of fear ought to be activated. In the airport, bomb. You know, that kind of stuff. So gut feeling makes a difference. Anyway, so behavior in economics, we tend to emphasize on how economics looks at reviewed choice. But of course, a lot of things is going beneath reviewed choice. But beneath reviewed choice, there's still consciousness. Beneath consciousness is unconscious. And there are all kinds of things going on here at the genetics, hormone, and neurotransmitter level. Okay, so this leads me to talk about this study. The focus is on GABA. This is not the most common system of neurotransmitters. Usually people think about dopamine and serotonin. Dopamine being connected with reward more, serotonin is more connected with harm. But GABA is actually the major inhibitory system in our brain. In particular, people who are anxious are often suffering from malfunction in their GABAergic system. That leads to the discovery of Valium, is the most famous diazepam, which actually is an agonist for GABA, so that people who cannot stop worrying can take the drug and strengthen their brakes. Don't think so hard, you know, cool it. Anyway.
So keep my students away from
As it turns out, that
I think he might be, you know.
I may need some GABA, I think.
Just a tad.
Anyway, so,
Or bad.
so there have been pharmacological studies about human risk-taking incentivized with GABA treatment. It turns out, not surprisingly, taking GABA actually enhances risk affinity in humans. The candidate gene, now talking about the 3 billion, right? I don't know any biology, I still don't know any biology. But my collaborator, the schizophrenia researcher, nothing about her directly. Anyway, her lab actually discovered, I think 4 of the 10 that she supplied to us to analyze. So any one of this is 1 over 3 billion. She supplied 10 to us, so it's now 1 over 300 million. Okay, sort of, I mean, factor of 10. And we just studied the connection in the following way. Every SNP in us, all of us have the SNP, okay? It's a matter of whether SNP comes in 2 DNA letters. So this one is like CT or AG. So one of the letter will be more than 50% prevalent, and therefore the other will be less than 50% prevalent. So for the sake of discussion, we just look at little m, minor is less than 50, major is more than 50, and all of us, for every SNP, can be classified this way. Either we are minor major, or major major. This is symmetric. The hypothesis is the stuff that she supplied us may somehow be linked to responsiveness to familiarity or behavior. Sorry. The gene predict behavior. We've just discussed just now, the Tokyo, Beijing. The gene predicts maybe an emotion-based region of the brain, like the amygdala, and the amygdala predicts behavior. So it's a three-way hypothesis. What we discussed just now is the initial stage of this study. With this study, this is demographics, we found 7 out of the 10 SNP that came from a different lab. And she's like not a great friend or anything, she's just another lab. So it's very independent and arm's length. Okay? 7 of them showed nominal significance. 1 of them barely survived 10 multiple testing by 10. But so this is the in-principle finding, but it's already very interesting. Moreover, in every case of the 7, the minor allele is linked to less familiarity bias. And The minor allele tends to be connected with people who have left Africa. Basically, we all left Africa. So the question is, the Africans, okay, presumably have more major. But after leaving Africa, the point about evolutionary biology. The minor allele for several of these SNPs are under positive selection. Okay? Now I'm also telling you the minor allele is linked to less familiarity bias in this task. So we did another thing with Nat here. He can maybe support or reject our claim, right? Because this is a statement about not needing multiple testing correction. We do what we call a genetic load analysis. All of our subjects can be classified in terms of the number of instances of having minor, because minor is the thing that is linked to not having less familiarity bias. So 0, that means these subjects have only major. All 7 SNPs, always major, 108 out of 325. 1 minor, 1 of the 7 is minor, 59. 2, 43. 0, 1, 2 is 200, 210. 91, all minor, no major at all. And then a few blurbs here. This relationship, you see, the odds ratio for choosing familiar is 1.0, exactly 50-50 for the 0 minor, and it's 0.4 for the 91 all minor. Okay? This relationship is 0.008. We claim that this is a behavioral finding that holds water. So you might give us a hard time later. Okay? So this is an illustration. So in particular, one of I didn't show this thing because I know it's being taped. So I redacted the identity of this gene. But this one, oh, we can see it. I hope you cannot see it. Anyway, this one is 40.4% prevalence. So we use that thing to select for a second stage 37 subjects. 15 of whom have major for that SNP, and 22 have at least 1 minor. We did 80 trials for 20 cities, now all domestic, no more Tokyo, and so every city is matched to 4 amount. I should just show you the task. So this is a totally non-fancy imaging task. No color, no bells, no whistles, right? All we want, we're talking about consciousness. Subjects are consciously looking at a city name and an amount of money. That's what you look at. And this is another amount. A few seconds later, this is when you decide whether to take the amount or to take the gamble. Anything goes for 80 times. There are 20 cities. These are the cities. Subjects then provide rating of familiarity subsequent to the scanning. So, they're at least not conscious of the familiarity task itself until after the scanning. So the hypothesis is using how to use a Smith utility to model familiarity bias. It's super easy. See, this is a CRI utility function, x to power r. And the only innovation, the Smithian innovation is there's a baseline risk aversion, sort of a power index, plus a sensitivity to familiarity rating. Question is R1 0 or not? And the answer is, it is actually 0. But no despair. Why? Because for the 325 subject, we have an principal finding of 0.008. For the 37 subject, we didn't find it. Big deal. Here's the next one. We know their genes. 15 of them are type 1, 22 are type 0. When we added a deep gene dummy, baseline risk aversion remained the same, but the one with the major actually showed significant sensitivity to underlying familiarity rating. So it's as if I have 22 normal EU and 15 actually Smithian. So 22 Savages, 15 Smithians. Anyway, so this is all the overall thing. I didn't show the name of the gene. Good. Now it's somewhere here, and then right here. So you see, the major, familiar, unfamiliar, minor. See, it's like that. So in the imaging finding, some things you always want to check. You want to make sure that reward connects with the reward region, like more dopamine rich, and we do find that. So EV correlates with striatal activity, so does lesion utility. It's also the right part of the brain. And for the novel finding, this is really cute. Amygdala activation is both predicted by the genotype, namely major, more activated. And when they're more activated, it also predicts more familiarity bias. Okay, this is the behavior. So the two-way hypothesis is supported. Discussion. So this original thinking that GABRB2 linked to the GABA contributes to, like anxiety modulation, it seems okay. DLPFC, maybe I should have mentioned. We actually did a whole brain search. In the whole brain search, exactly 2 regions showed concurrent activation. The relationship, I just thought about this relationship, predicted by genotype and predicts behavior. All concurrent to relationship is only 2 regions, amygdala and DLPFC. And DLPFC have already been associated with risk-taking in other papers. So it confirms it here. And it's consistent with the role of the unconscious processing of emotional inputs. For example, so this is like Keynes all over again. Now I have about 8 minutes. Okay, let me do a quick 8 minutes. So there's a second paper. Okay, it's an imaging study of strategic uncertainty. Third quote from Keynes. I told you it's a 3 Keynes talk. So Keynes, in the same section of his general theory, also talked about, after the animal spirit, talks about how, because the Americans tend to do high frequency trading, so he thought that maybe the stock market should be regulated like casinos. I think the Singapore government will be listening very carefully. Anyway, so in particular, in the same year as the Treatise on Probability, Frank Knight talked about differentiating between measurable and unmeasurable risk. But Frank Knight was thinking about entrepreneurial risk, which really, in many ways, is strategic in nature, right? So entrepreneurial risk involves other people. Most of the time, we do non-strategic risk. So this is a paper in 1994 by Kammerer and Karjalainen, in which they tested an intuition. Is strategic uncertainty a form of ambiguity? If so, then you would expect for example, in the machine penny game, you might prefer to just play it non-strategically. Pick a coin, toss it, either I win or you lose, rather than play, because this is like more ambiguous. So, not surprisingly, this very short paper published in a proceeding of, I think, IFREE, 1990-something, confirmed it. But subsequently, people have studied coordination game version of the machine penny game. So instead of I win, you lose, you win, I lose, you win, I lose, we win together or we lose together. Our design has, by the way, this has been studied by 2 or 3 other papers as well. So our design has a further innovation. We added a deterministic case. So instead of you win, I win, you can also, all of us can get a fixed amount for sure. For example, if this is x over 2, then we are also checking whether people are ambiguity or risk neutral. For that matter, we can also say that Kammerer and Karjalainen's conclusion might be premature because they compare between unambiguous and ambiguous, strategic uncertainty. They say prefer unambiguous. But unambiguous should be compared with x over 2. That wasn't done. And nobody did that in the literature, so our paper is the first when we actually added this design. By the way, the location is not LCR. In the scanner, they are randomized. So there's no like UD, all these things can show up in any way, it can happen. So there's an experimental design. In each case, machine penny, we have up, down, or we have a dice tossing odd or even. Coordination also up, down, and a dice. The hypothesis is, this is a social preference hypothesis. In some sense, we like to win together more than I win, you lose. And then in terms of interaction, if it is a competitive situation like machine penny, people might prefer a dice, so unambiguity. But if it's playing a coordination game, the hypothesis is people might actually want to be involved. You want to play the game because you're hoping to win together. That's the imaging design. Another application of the Smithian utility function. I just challenge you to think of another way to estimate or to make sense of this data. After all, we have 4 kinds of in principle risk attitude. So we just use the same X power but different potential, estimate different levels of risk solution indices using different dummies for the MS is strategic, right? Coordination, or matching penny strategic, matching penny non-strategic, coordination strategic, coordination non-strategic. Non-strategic means random play. So for the pure behavioral result, the significance are not super great. Only one of them is 0.01, and there's a difference between coordination strategic, they like it most, and matching penny strategic is the worst. And you can see it's sort of roughly there, but a lot of overlapping confidence interval. But here's the surprise. Everybody is essentially ambiguity seeking. No matter how ambiguity seeking. Okay, so all the coefficients estimated are negative, but still, matching penny is the least interesting. People are most risk-taking when it's strategic and coordination. Again, we have the reassuring finding, EV and stuff like that, correlate, coordinate, and then we again find a middle connecting with this interaction. And also OFC, which is linked to the PFC. Both regions actually linked to a paper published by Camera and Ming. Xu Ming is a Caltech student who has currently at high school. He had a science paper in 05 doing a neuroimaging study of ambiguity aversion. That paper is actually the second paper using imaging to study ambiguity. The first being John Descartes' paper, who was published in Management Science and has been by and large ignored in the literature mostly, but not by me. Okay, and then anyway, and now this is me. So interestingly, even though Ming's paper is non-strategic about ambiguity and familiarity, this is about strategic uncertainty. The same 2 regions show up. Okay, the source of source preference is strategic uncertainty. Actually, one of them is social preference, so that's not a big deal. But another one is why the difference in preference between tossing a coin and playing consciously. One hypothesis is actually China's view in 2000 JEBO paper, in which you can think of responsibility alleviation. Whenever you toss a coin, you're less responsible. So if you like it, then you want to toss a coin. If you don't like it, you like it, you don't want to toss a coin. If you don't like it, then maybe you want to toss a coin. And then, of course, Keynes' quote, actually the third quote, is in some magical sense is linked to attitude towards ambiguity. Okay, and so Keynes is really making the point that there could be recreational value in risk-taking, even in stock market trading. People can go to the straight market. And as we have just noticed here, in all 4 treatments, people seem to derive consumption value from being engaged at different levels in the 4 treatments. And moreover, we also know that in studies of pathological gamblers, there's differences in taste for strategic versus non-strategic. And you do see mostly slot machine addicts, they tend to be female. Poker addicts tend to be male. I have, 35 seconds. Okay, so this is a surprise. I don't think you expect to see a slide of Robert Aumann writing a paper with a single word title that is not like mathematical economics. And it's 7 pages with no equations, okay, published in some edited volume. But Aumann, of late, is advocating paying attention at the role of consciousness. After his great success with common knowledge, he's gotten from knowledge to being conscious. And I think Aumann's paper is very timely because we are also now aware of a parallel literature. Maybe you can think of Christian's rational inattention work. There are also other people like Cario and Mariatti in 2000 already start on strategic ignorance, and Venerable Thiro's follow-up paper in 2002 also already start on strategic for recall. Amnesia, kind of amnesia, selective memory. And so it seems clear now. We have milked this a lot. And Herbert Simon sort of suggests that we should worry about boundedness in computation ability. I think bounded rationality has been tended to be connected with this a bit more, sometimes with this, but certainly we should spend a bit more time on bounded consciousness. Now I'm 30 seconds over, so this is a picture taken from a co-authored book by a neuroscientist called Pierre Magistrati and a psychoanalyst called François Anzemé, published in 2004 in French, translated in English in 2007, and they built on the neuroscientific fact of neuroplasticity. As it turns out, our memory, our attention, our interactions are encoded at the synaptic level, literally in changes of the dendrite configuration between neurons. So our brains are constantly changing. It's impossible not to change, not even in your sleep. Now, in the process, of course, we can consciously try to link pieces together, have an argument, prove a theorem. While we are living, while we are alive and breathing, lots of other changes are happening and they are not connected. We cannot consciously access all that is happening at the synaptic level, naturally, clearly, but it's happening. So these authors are suggesting that besides a conscious reality, we have an internal unconscious reality, which is like the union of all these bits and pieces of changes. But some of these pieces of changes can actually sort of recombine and create new reality that can lead to fantasy. So internal conscious reality leads to cognition, unconscious reality leads to fantasy. Somatic state is modulating both cognition and fantasy, and maybe selecting things for you to look at, or maybe to dream about. In this picture, I think there is a weakness because it suggests that people have two kinds of action. I think for us, in decision making, people decide whether decision can actually come from a combined influence, as suggested by Keynes, right? Kind of, I don't know whether it's a balance. Keynes' wording was quite strong. He said, people just work because of drive, urge. Well, I don't think he really meant that, right? So really, it depends on your decision. When you're proving a theorem, presumably you're not using fantasy. But when you're in a, when you're in a bar, well, a lot of things can happen. Anyway, okay, so the concluding remarks is our gamma circuit may actually nudge us to choose the familiar over the less familiar, perhaps to ameliorate a sense of anxiety, even if you're not conscious of it. Evolutionary law already observed, right? The minor allele is in fact under process selection. And finally, I think biological economics is upon us.
Great.